Welcome back. We intended to do a video on the stock market today, but I don't have enough money to buy the 4S ticks API, and I don't want to do the basic tick, $5 billion ticks or whatever it is, because that's a really, really complicated algorithm. The 25 billion one is much, much easier. So I intend to go back and talk about like drift and calculating for what's essentially a random walk. But I'm going to save that for a minute because that was the hardest problem in this entire game for me to figure out, was the frickin' stock market on the 5 billion pre-forecast level. Super complicated math, didn't know what the heck I was doing. Finally cracked it when I got into the source code and figured out exactly how the stock market trends. But all that is to say, I still wanted to do a video, but I didn't have any other topics. Fortunately, YouTube's left a great comment on video 1 where he basically says that, he wants to talk about the YouTube algorithm, and I wasn't clear in the purposes of this channel, and I wanted to take a minute to address this. Sorry for the awkward pause. The purpose of this channel is to allow a junior developer, probably like yourself, to play second fiddle, to pair program with me. In software development, pair programming, partner programming, whatever you want to call it, involves two coders working on one computer, a senior and a junior. And the senior's job is to sit there and type code, and the junior's job is to sit there and watch him do it. What happens in this relationship is the junior dev learns a lot of lessons, habits about how to build software. Not just looking at source code after it's done, but what do I start with? Do I start with the return? Do I start by defining what I want to get out of a function? Do I start with what I'm sending into it? How do I handle basic structuring of edge cases? Do I write out my edge cases in tests before I start and do what's called test-driven development? Do I ignore my edge cases and just get primary functionality working? How do you know the answer to those questions? How do you know what works best? And it can vary, like on different applications and in different languages. How you do that it's always different. That's why there's so many different modalities to software development. But pair programming really helps a junior dev learn through just watching someone do it, which of those modalities to choose, how he's going to choose to attack software when he becomes senior. So that's what I'm hoping you get out of it, is the ability to sit here and watch me code. What I'm hoping I get out of it is the same thing a senior dev gets out of pair programming, which is a rubber duck. Talking about the problem you're trying to solve makes your solution clearer in your mind. If you just sit down and code without describing what it is you want to do, without writing pseudocode that says this is what I want to accomplish, without documenting as you go, if you don't do any of that stuff, you're going to have like spaghetti code's the wrong word. You're going to have code that doesn't do what you want it to do. You're going to have like a function that doesn't return a value because you'll send in the values and you'll type up the function and you'll forget to return anything because you didn't tell someone or something that now I am creating a function that takes in the amount of money the player has and returns from that the number of servers the player can buy. If you say those words, you'll remember to put the return in there. If you don't say them, you very well might forget. It happens to the best of us. And this is a really common idea, rubber duck debugging. You can Wikipedia it, I'll give you the top line. It originated in like the 80s, early 90s, where like programmers would put like a rubber duck or some other inanimate object on their desk, and they would, as they were going through their debugging steps, they would talk to the duck and they would say, and now the function is processing a list of servers. And then by saying that, they would have to read the function and make sure that it was processing a list of servers. And then they would go to the next line and they would say, and this line does this. So just simply by explaining it to an empty audience, I get something out of it. So I'd like to address the YouTube algorithm, because there's a lot of creators on YouTube, young people, hell, I'm not young and I'm doing it, who think certain things about YouTube's algorithm, a lot of which are not true. And I'm about to give you the straight dope on what actually goes in to making your videos popular or not popular. The difference between having 0 views and having, well, let's say 500,000, 200,000. You know, I'm not going to say the difference between 0 views and 20 million views, because once you're on that tier, other things apply. There's partner programs and support from the platform. But let's just talk about like early stage. Is a video going to be successful or is it not? If you Google what makes a successful YouTube video, you're going to get a million different people telling you a million different things. Everything from how long the video is, to how many people comment on it, to how many people subscribe as a result of it, to I mean, there's literally hundreds of metrics. And YouTube, well, when you ask someone who doesn't know what's going on behind the scenes what the metrics are that matter, they're going to tell you the metrics that they worked on and that worked for them. And if they're a successful creator, maybe they do have some insight into it, but hell, a lot of them aren't. A lot of them have never made a YouTube video in their life. They're just regurgitating what they read somewhere else, or applying what they learned from Google SEO, like the search engine, and assuming that it works the same on YouTube, which is not a terrible assumption to make. And we're going to talk about why that's not a terrible assumption either. But yeah, let's just, when people say the YouTube algorithm, what I hear is a graph data structure with edges that are weighted based on the outputs of a neural network machine learning algorithm, wherein Google encodes the multivariate linear regression statistical function of an LTV metric, lifetime value metric. So Google is performing statistics in order to get LTV, which it is then sending into this neural network. I could leave it there, but I'll tell you how they're getting LTV as well, because that's like the key point to all this. LTV, lifetime value. Really, really easy to get. We do it all the time for lots of different services. It's formulated by like randomly sampling the population of YouTube users. Active, not active, just a random sample of everybody who's got an account on the platform. A big one, big random sample. And you do this over an extended period of time. You do it multiple times, and you determine the total amount of revenue generated by those users in that time frame. And when I say time frame, I'm talking like 5 years. You would go back, and I'm just making that number up. It's going to be a long time. It's not going to be how much did they generate today. It's going to be in the last 5 years, how much revenue did this person generate? And so you take the random sample, and then you just get that number. You know that number if you're Google. It's in your database. You just pull the sample, pull that number, how much revenue. Then you send that revenue in as the win condition of either like a genetic algorithm or well, actually, no, you don't actually send it there to the neural network yet. You take that value and you do a multivariate regression on it. Multivariate regressions are, I mean, it's complicated. If you know what a linear regression is, it's a multivariate version of that. If you Wikipedia linear regression, it's actually pretty easy to understand, but think of it like in Excel, a trend line or curve fitting, or taking a random sampling of data and trying to draw the best fit. Say, I don't even know. I don't want to go into much more detail than that. They take a multivariate linear regression analysis of that lifetime value metric. And then they send in to some kind of a neural network. I'm not sure what algorithm that uses because it doesn't really matter. The results of that regression analysis, and the regression analysis generates a matrix, a gigantic matrix, which if you're a human reading it means fuck all. It means nothing to you because it's such a big set of data. And it's all saying like how this one data point, like say watch time, how watch time is correlated to lifetime value. But then it says, and what I'm describing now is a single linear regression. You would ask how engagement, how leaving comments is determines the lifetime value, how it's correlated with it. But then in the multivariate version, you take that long list of things you're tracking and multiply it in a second dimension. So then you would also ask, does engagement influence watch time and thereby influence lifetime value? I'm not sure if that was easy to understand, but I think you get the idea that it's a giant matrix of essentially just numbers from 0 to 1. They feed that into a neural network, and it calculates through a black box. I don't know how it works. I doubt anyone at Google knows how it works at this point. It calculates whether or not various different strategies would yield higher lifetime values. So that's the algorithm in a nutshell. Now, why is that the algorithm? Let's posit that Google's goal is to make the maximum amount of money over a long period of time. They don't care about making money today. They care about having a higher valuation as a company in 10 years, in 15 years, over the continuous growth period is what we would technically call it. That metric that determines what your continuous growth over time is CAGR, C-A-G-R, the compounded annual growth rate. CAGR is used by everybody in business, everybody on the stock market, anybody who deals with revenue knows how to calculate CAGR, and they know the value of it, and they want to know what our CAGR is for different strategies. So let's assume CAGR is the primary goal of the YouTube algorithm, maximizing that, because maximizing that would directly increase their stock price, bottom line. And maximizing nothing else would increase their stock price. Only maximizing CAGR, with the exception of like, having better hiring practices. That might increase their stock price a little bit, but not if their compounded growth rate doesn't go up. The goal of having the better hiring practices is making your compounded growth rate go up. So, lifetime value is a direct indicator of CAGR. It's simple arithmetic. Your lifetime value of your users, it's like 100 times that over 100 minus the last version of it, like from a year ago, it yields a percentage, and that's CAGR. So lifetime value is the only variable in that equation. So then we know for a fact that the algorithm I've just described maximizes CAGR. But why do we say, like I started this out by saying it's a graph data structure. And it's important that it's a graph because they're recommending a number of videos to you at any potential time. You look at the sidebar, there's 30 videos there. You look at the homepage, there's 100 videos there. And they're selecting those videos and weighting which videos come to the top based on a graph data structure with weighted edges. How are they getting those edge weightings though? Let's posit that the analysis they're doing is probably being rerun daily. If they were to rerun it weekly, it would move too slow. If they were to rerun it hourly, it would change too often. So let's just say, for the sake of argument, it's rerun daily. Then the next step for that, well, if that's where we stopped, we said we're going to implement algorithm 1 and then rerun it daily, you would actually not have a YouTube algorithm, a successful algorithm, because they're using so many variables in it. The number of variables you use in a machine learning network can directly impact your ability to get good results out of it. Same goes for any statistical analysis. This is a phenomenon called p-hacking. Have you ever seen, like, on a news website or something, like a reputable news source, like some article that says chocolate linked to lower rates of heart disease? Something that seems like there's really no reason why this should be true, and no scientist can give you a real reason why they think it's happening, but some amino acid found in the chocolate was correlated to people having fewer heart attacks. A lot of times those studies turn out to be false. And this is a problem with data science. P-hacking is when you look at a ton of variables and then you look at a ton of different effects of those variables. So take the chocolate study. And they probably didn't look at just chocolate. They probably had an idea of, we're going to try to determine something that will lower heart attack rate. But then they looked at chocolate, and they looked at popcorn, and they looked at exercise, and they looked at how much money you make, and they looked at, do you live within 10 miles of a fracking operation? Like, they just kind of threw shit at the fence, just saw what stick. Saw what stuck. In statistics, there's something called the alpha level. The alpha level is a value that you assign just as part of the methodology of doing a statistical test that determines, because you can never conclusively prove something or conclusively disprove something, but you can say that I am 95% certain that this thing is true, or I'm 99% certain, or 99.9% certain. That percent certainty is the alpha level. So like if you set an alpha of 0.05, you say I'm 95% certain. But what that means is that 5% of the time, I'm wrong. I'm 95% certain, but I'm wrong 5% of the time. That alpha level is assigned to every single test in your multivariate linear regression. Every single one of those values has a 5% chance of being wrong, or a 1% chance of being wrong. If you run it with enough variables, you will get a result. There is no guarantee that that result is accurate, but you got the result, so you can publish it. You can write that news article on chocolate lowers heart attack risk, which does it? Or did you just test 30 different variables and chocolate came out with a successful result on this test? Can you repeat it? That's why repeatability is key to science. That test could not be repeated. So that's the problem with the algorithm I described. It would fail to the p-hacking problem, specifically because we know that Google's testing hundreds of variables. But you can solve p-hacking. Let's say, imagine a graph, which, let me start over. What is a graph? Imagine 3 cities, and we'll describe the distance between the cities. Let's arrange them in a triangle, describe the distance between the cities in miles. You know, city A is 15 miles from city B is 25 miles from city C, and city C is 20 miles from city A. The numbers don't matter. What that kind of structure gives you is math that you can do. Like, you can calculate how far is it to city C through city B. You just add up the distances, right? Makes perfect sense to you. A graph is like that. But instead of using something as simple as distances, the edges are weighted. They're assigned weights. Those weights are computations. How do I want to describe this? Those weights are computations generated by that linear regression analysis. But we already know that regression analysis could be wrong. So the way you solve this is you assign those weights not all at once. You don't come out and say the chocolate reduces heart attacks on the first test. You assign the changing weights. They're running this every day, remember, on a stepwise basis. So if the weight today calculates as a 2, for example, and tomorrow it calculated as a 5, you wouldn't just change the algorithm from 2 to 5 on that weight. You would change it to 2.1, and the next day, if it was still true, 2.2. The next day, if it was still true, 2.3. So you would incrementally change them. That would be like introducing the change at a specific delta t. Obviously, if the change is so insignificant that it would be small enough to be introduced in one step, it would just be introduced in that step. The reason why that's almost certainly how they do it is because any other solution to the problem doesn't solve p-hacking. Any other algorithm you could describe won't solve p-hacking unless it has that stepwise incremental change. What that stepwise change creates is called Brownian motion, a Brownian walk. And if the numbers, and we're talking about like infinitesimally small differences from day to day, but if they're just, the changes are just random chance, they will still change from day to day, but they will basically hover around a certain value. So you sample a random selection of users every day, and you calculate LTV on them, and you run them through all these algorithms, and you get a number out of it. And from day to day, that number is going to change because you're taking a different set of users. But it's going to change around a point. It's going to go up 1, down 2, up 1, up 1, down 1, down 1, up 2. Like it's going to hover around a 0 value or a true value. What this means is, well, one, you've solved p-hacking, because if it's higher one day and lower the next, it doesn't jump that entire distance, it just changes a little bit. 2, you've given a metric that you can show to like the VP of whatever bullshit title he has to be like, we have noticed a trend over the last 6 weeks in this domain. In this variable, we've noticed a trend. It would seem that you might say, we earn a higher lifetime value from users when those users have an increased watch time. That might be something you would take in and say, and you would say that because the Brownian motion day by day would have a drift to it, and you can calculate drift. It's a calculus function, well known. You solve for drift. You would say there's a drift to it, and the drift is in this percentage value, and you take it in as part of a report, and it's good. So that's reason 2. Reason 1, it solves p-hacking. Reason 2, it's a nice metric that you can summarize easily. And reason 3 is it would allow Google to like change that metric, influence that metric with like human intelligence. And I'm going to leave the human intelligence question alone for now, and that's going to be a whole other discussion. But what we've just described, an algorithm that generates a graph that takes a random sample to determine lifetime value, that generates a multivariate linear regression analysis of that sample and passes into a machine learning algorithm to generate the graph being what videos show up in your sidebar. That algorithm, when applied with a stepwise function that creates Brownian motion like I just went through, would create, like provably would create the, well, I don't want to say most profitable, because that's not, it would create the highest cager value. And we know that cagers are really the most important value to calculate for. It would maximize the compounded growth rate. It may not make the most profit. It may do something like improve revenue, which doesn't necessarily improve profit. Profit is revenue minus cost. But we know we want to solve for cager. This is getting too complicated even for me. I'm losing my train of thought. Secondly, I would say that algorithm uses the full sum of knowledge at Google's disposal. So those are kind of the 2 points I want to make about it. It's provably the most accurate, and it provably uses the full sum of knowledge they have. It can take in any data they track, can all be entered as part of that regression analysis, and it will generate a value. So it uses all their data, and it's provably the most efficient solution for what they want. And since those two things are provably true, we know that this is provably the best algorithm, or something very, very similar to this, provably the best algorithm for them to use. But this algorithm would have other benefits as well. When you structure, like when you're doing the regression analysis and doing the stepwise stuff, like the algorithm never has to change. Like you don't have to send your senior engineers back in there every day tweaking stuff, because you're just running the same tests every day on new people, on new data. You're just running the test again. You don't actually have to change the code of the algorithm. What you do have to do to improve the algorithm is find new sources of data. Since we've established that this algorithm would use 100% of Google's data, of everything they're tracking, well, just track more stuff, have more variables. And so improving the model is as simple as like an engineer at Google, junior level, senior level, whatever, saying, I think we should track X, like X metric. We should track this because I have a hypothesis that this leads to higher customer value. And based on what I know of the workflows at Google, I don't even think that would require like approval from management. I think it's something that like you sitting at your computer as an engineer of any level could hack together in like 4 lines of code, because Google's got this giant internal SDK, software development kit, for like all of their own coders. They don't release this. This is only internal to Google. If you're working at Google, sitting at a Google computer, you can type into whatever programming language you want. Python, Go, Rust, JavaScript. They don't care. They've implemented it for everything. You can type a line like create giant redundant data store, open parentheses, close parentheses, and it will return to you a giant open data store. So we know that those functions exist, that SDK exists. So it's likely that there's an SDK that's like track user variable, and I'm going to describe that variable as like watch time. And here's how I want to track it. I want to start when somebody clicks the play button and stops and stop tracking when the video stops playing. And they have to write the code to say that's exactly what I want to track, the length of time the video played. But once they do that, like my guess is they just push that change out, and then it goes into some kind of CI/CD pipeline that would run like an A/B test on it. So what's really interesting about this algorithm formulation is that you can what's the word? Stock trading term. Back test. You can back test it. You can say, run the algorithm without the metric I just told you to track. And on the same set of users, run the algorithm with the new data. And tell me which one is more profitable, or which one does the machine learning algorithm think is more profitable. You can just A/B test, literally say the new data increases profitability. We can prove from a specific section of users that we have sampled in this subset. Well, you wouldn't say we can prove, you would say we are 99.9% confident that this new data that I have developed, that I have told you to track, increases the profitability of YouTube. Done. And any engineer can submit that code into the pipeline. And if it passes the A/B test, most likely it just gets rolled in automatically, or it goes into a list to be reviewed by some senior coder who just signs off on it. Another reason why I'm fairly confident this is the algorithm or something really similar to it, the algorithm I described to be really good, really resilient against like changes in the cohort of YouTube users. It would adjust automatically by resolving for lifetime value every day. Like if usage of YouTube was to shift drastically, like we'll take the shift to mobile. A lot of people using mobile devices to access YouTube these days. That shift happened gradually over time. And it's likely that this algorithm was in place 15 years ago. Like what I described to you is not a new thing. Like they could have done this 15, 20 years ago. So as the shift to mobile happened, what the algorithm would have done is, as more people started using mobile, it would prioritize videos that performed better on mobile. I don't know what that means. Nobody has to know what that means. You don't have to say this type of video performs better on mobile or earns Google more money on mobile. The algorithm would just solve that. And this is really important because, I mean, the shift to mobile is like a giant overarching, like, obviously you're going to want to optimize for mobile, but why don't we take a shift that's not so overarching? What about like the introduction of YouTube Premium and YouTube Live? Not a lot of people use either of those. I would guess less than 0.1% of people on YouTube use YouTube Live, and probably less than 3% use YouTube Premium. But we know that YouTube Premium and YouTube Live are more valuable to Google. They have higher revenue growth when people sign up to those services. They are paid services. So this algorithm would also compensate naturally for having different value, for differentiating users based on different values of the user. Like a good way to put it, well, let's just establish that two users can have exceedingly different values even if they have the same watch time. I think we can all agree that if you pay for YouTube and you watch 1 hour of YouTube a month, you are far more profitable than somebody who does not pay for YouTube and watches an hour of YouTube. So assuming users have different values, by using an algorithm that solves for lifetime value, the videos that end up in the sidebar will not necessarily be the videos that engage the most users. You don't necessarily want to engage the most users as YouTube. What you actually want to do is engage your most profitable users, and the algorithm naturally solves for that. Like, say there were two creators, and creator A was making, I was going to take Minecraft videos because that's a great example, or like toy opening videos. Minecraft may, I was going to say something that targets very young people who don't have a lot of disposable income, but I think a lot of 30-year-olds with good jobs play Minecraft too. But let's take toy opening. Kids watch that. Kids have no money, and their parents watch that. The only value to those creators is coming from ad revenue. If we assume that kids never buy a premium account, obviously their parents can buy one, but let's just assume that nothing but ad revenue, nothing but free users. Compare that to a channel that targets high income earners, cord cutters. Let's say you had a channel that targeted specifically cord cutters. It's likely that the audience of that cord cutter video would be more likely to have YouTube Live, because YouTube Live provides TV channels, just what it does. So to YouTube, if you got some number of users watching that cord cutting channel, and they could prove that that cord cutting channel slightly increases the likelihood that that user watching it buys one more month of YouTube Live. Just an infinitesimal amount. That infinitesimal amount would blow out of the water many users who just watched that free video, even if they continued watching YouTube for weeks and weeks after that. Even if they were highly engaged with the channel, they loved it, they kept coming back. They're just not worth as much to YouTube as somebody who pays for the service. And Google wants people who make them the most money. So it's not as simple as just getting the most views. It's about getting the best views, the most profitable views for YouTube. And channels will be successful, and they will be promoted in the sidebar and on the homepage if they're the most profitable video for YouTube to promote. Bottom line, if that's the one, and let me take a step back and just clarify, that does not mean that you watching that specific video has the most value. It could mean that because you watched that video and that was a really engaging creator, like I wish I knew any popular YouTubers. Oh, what was that guy? Jake Paul. Or Mr. Beast. Mr. Beast is on top of the game right now. What YouTube cares about is if you watch Mr. Beast, you are probably going to come back and watch the next episode when he releases it. And you're probably going to watch the next episode, and you will become, like, it will spiral into you going from watching one video to you watching 100,000 videos over the next 5 years. Because you watched one Mr. Beast video, you're likely to do that because he's a very engaging, very friendly creator, makes interesting videos. Has nothing to do with the fact that he puts, I give away $1 million in the title of his video. Has nothing to do with that. It has to do with the fact that he continuously makes content that hooks new users into becoming part of the YouTube ecosystem. People see his videos on YouTube, they're shared with them by classmates or whatever, and they become YouTube users. So Mr. Beast has more value to YouTube than the ad revenue they earn off of his videos. His value is his video revenue plus every other video, which are all revenue generating for YouTube. You see where we're going with this? If you're a creator who wants to target the masses, that's fine. There's nothing wrong with just going out there and being like, I want as many hits as I can get. Because that kind of approximates success. Like if you get the most hits, then you're also likely to bring the most new users to the platform or re-engage users that, let's call them lapsed users, people who are not often visiting the platform. But like all of these different metrics, like did you create a re-engaged viewer who then went on to watch 10 different videos? This is the core of the algorithm. And you don't have to code, like you don't have to know that's the core of the algorithm for it to work. That's the brilliant thing about the algorithm I described. It just works, and it works for users of different valuations. So if you engage one dude who becomes a premium subscriber, that's better than engaging 100,000 dudes who don't. Well, 100,000 is a bit of an overstatement. I actually don't know how much premium is. I know how much YouTube Live is because they advertise it to me all the time. If we assume that Google's profit margin is 50%, on both ads they show you and YouTube Live, then the ratio would be 35,000 to 1. One single engaged person who signs up for YouTube Live some point in the future is worth more than 35,000 equivalently engaged people who do not. So there are many, many ways to get inside YouTube's algorithm. If you read something on the internet that says all you got to do is make longer videos, they don't know what they're talking about. Maybe that helps. Maybe it doesn't. People at Google probably don't even know. But talk about that for a second, the people at Google, because I think talking just about the algorithm fails to take into account the human intelligence that is sitting over there at Google and can make smart decisions. So like watch time is the perfect metric, because if you asked me, I would say, yeah, watch time is probably directly correlated with engagement. I would assume that's true. It makes sense. And you can't just let the algorithm decide everything. Like the human aspect of it and being able to say, yes, that makes sense, or no, that doesn't make sense, can help to shape the algorithm or the resulting weights. Remember when we talked about like 20 minutes ago, the Brownian walk? Like you're taking this random sample every day of YouTube users, and then you're doing all the math on them, and then the number changes by a little bit. Or maybe it changes by a lot. Like maybe you just picked a sample of users that are really different, just completely randomly. You picked a sample of users that are all millionaires. That would drastically change lifetime value calculations. So you get this Brownian drift. If you are part of the human intelligence team at Google, the people who are assigned with looking at the drift numbers, maybe VP of whatever bullshit, title, that guy, or his junior, the person right under him, or like a director of analytics, or a data scientist working at Google. Your job is to apply your human intelligence to that Brownian walk. So if you see, let's say on Tuesday, you go into the office and you look at the results of your algorithm, and you can see that the weight of metric A of watch time is plus 5 points. And you can see that the weight of engagement is plus 6 points, like engagement being the number of comments on the video. And then you come in on Wednesday, the next day, and you look at the algorithm again, and now it says watch time is -2. And you're like, well, that's really different than yesterday. Yesterday it was +6, today it's -2. And the next day you come in and it's like +12. I'm just throwing some numbers out there because the point I want to get to is, in every case, the algorithm, the data didn't change, the sampling changed, but you can assume the sampling is random, statistically random. And while that changed, and while that does have a small percentage chance to affect your data on any given day, if you were looking at this data over, a period of a week or a month or a year, you would start to see, God, I have to go back. What the algorithm is solving for is lifetime value. Now, there may be two equally good paths to get to lifetime value. It might be that you find that increasing watch time gets you to the maximum lifetime value, but it also might be a really close second that watch time has nothing to do with it and it's all about engagement. Like, those theories could both be true. I need a better example. Hope I can find one. Okay, let's take user's income level. Let's say you've got two competing theories, and on Tuesday you walk in and you find that one of those theories is proven out, that watch time is determined to be the most likely factor to change to create high lifetime value. But on Wednesday, you walk in and you say, wait a minute, a user's income is far more critical to determine lifetime value. And it like alternates back and forth like that, like either every day or every couple of days, or, you know, just, it seems that two competing strategies are being offered. What that means is they both have functionally identical lifetime values. Okay? So if you just let the algorithm run, it wouldn't prefer either strategy because as best it knows, those are functionally identical. But you're a smart person sitting in a chair at Google trying to think, okay, what is Google's strategy? What did we talk about at the board meeting? They said that they really want to target higher income users because they're talking about in 6 months releasing this YouTube live service. It's going to be expensive, but they're also talking about how, you know, a high income earner is more likely to become a business customer, but that's not actually in the algorithm yet because nobody's actually written that code. But, you know, everything seems to revolve around this idea that Google would prefer higher income people to watch it. We would like to engage higher income people. But the algorithm is giving me two strategies which are, it thinks are the most, are equivalent, are both going to get us the highest value. But I know because I'm sitting here, or my bosses think, or someone has told me, we want to focus on one of these. That's where the human intelligence comes in. And what that looks like is, since we're working with Brownian walks, you just apply a drift to that Brownian walk. You say, all right, well, if the target value that it gives is 6 for income as a metric, then we want to take a step of 1 unit every day. So it'll take 6 days to achieve the graph, the list of videos in your sidebar. It'll take 6 days for those to approximate what the algorithm thinks is the best combination of videos in your sidebar. Alternative, lost my train of thought there. So what I was trying to get to is, let's say we come in and there's a value of 6 and the default is a stepwise of 1 per day. What you would do is you would adjust that stepwise value. You would say for high income earners, I want it to be a step of 2. And for watch time, I want it to be a step of 0.8. That way, if it's true that the algorithm thinks that they are functionally identical, it'll still alter between the strategies. It'll still tell you, let's change the values of high income of videos that engage high income earners versus videos that engage people who watch longer. But it will change it in a way that drifts. Over time, it will get to the point sooner of now the videos in the sidebar are there and they engage high income earners. So you're introducing artificial drift. That's the key. That's what a human can do. Introduce the artificial drift because you've already got the drift generated by the algorithm and you're you're accepting that that drift exists with the stepwise changes. And now you've got a human sitting there saying, let's stepwise change just a little bit faster on that variable because I've got a reason. Now, I think I've covered almost everything. The last thing, and I hope this is the last thing, and I hope this doesn't run on for another 10 minutes. The last thing I would say is that, yes, you can have people at Google shifting the numbers, saying, I personally believe that the number of comments is the most valuable metric to track. And I'm going to try to tweak the algorithm so that engagement gets a higher benefit. They can do that. It's unlikely that any single engineer can tweak the algorithm for everyone. But what I would do if I was Google, and I don't know how they do it, if you were an employee, an engineer employed at Google, a data scientist, I'd give you a slice of the users. I would say, all right, you can tweak the algorithm directly for 5% of users or 1% of users. Only that 1% will see what you do, but you got full control. Do what you want. If you abuse that trust, you get fired, right? So what that results in is people with opinions can do things like increase watch time, increase engagement, and they can do it in the ways that the commenter, or back to the commenter from the YouTube video, has suggested, like making a certain type of video may increase watch time among neophytes or whatever. And if watch time is a valued statistic by a human at Google, they can boost that. However, and this is the key, at the top of the food chain, the boss of that engineer, or that boss's boss, or that boss's boss, somewhere up there, there's an engineer, a director of IT, a director of data science. And he's going to look at everything people are doing. And he's going to say, I see you've been preferring watch time. Why should Google trust you? There's no evidence in the algorithm. The algorithm says watch time and high income, we'll go back to that. Watch time and high income are identical. That guy at the top is going to ask you, the engineer who really wants watch time to be the value they preference. He's going to say the algorithm says they're equal. Why are you changing it? Why should we trust you over the algorithm? It's all going to come back to that at the end of the day. Why you? And that's the same question I levy at UDMS or anybody else who thinks they know how the algorithm works. I've just described to you the only algorithm YouTube could possibly be using. Why should I trust you over what I've just described? Why do you know what works in the structure that's so damn complicated? It took me an hour to explain the basic operation of it. Why you? Because you read it? But in all seriousness, I don't mind engaging about this. I appreciate the comments. I appreciate the people having opinions. Just expect that I have them too, and I might disagree with you publicly in a video if it's egregiously wrong and needs to be said. Also, this was a comment on the first video, and I think that deserves a little bit of prime real estate, so it gets its own video. All right, see you next time for stock market stuff. Thanks for watching.